So just to summarize, we now know that the subnet our host resides on is 172.16.32.0. We also have worked out that the next subnet in the range is 172.16.48.0. It's important that you work out both the subnet that the host resides on as well as the next subnet. Now just to help you with an analogy, in the real world we have an odometer in a car or motorbike, something like this picture. It will roll over from a 9 to a 0. When traveling, if the rightmost value is 9 and you drive another kilometer or mile, that will change to 0 and the 0 to the left of it will move to 1. So in a standard odometer, if you had a value of, let's say, 7 zeros and a 1, because you've got a brand new vehicle, so that's the distance that you've traveled, let's say 1 mile, and you drive another mile, the odometer will show that you have driven 7 zeros 2 miles. If you had driven 9 miles and you drove 1 extra mile, that would display as 6 zeros followed by 1 followed by 0, in other words 10 miles. If you had driven 999 miles and drove an extra mile, that would display as 4 zeros followed by a 1 followed by 3 zeros, in other words 1,000 miles. Not that you would ever do this, but let's say you reversed the odometer. So you had 1,000 miles and you took 1 mile away, that would give you 5 zeros followed by 3 nines, in other words 999 miles. Now as an analogy, we have a binary odometer. If you had an IP address of 10.1.1.254 and you added 1 to it, the value would become 10.1.1.255. That should be fairly simple to understand. However, if you had 10.1.1.255 and added 1 to that, you would now get 10.1.2.0. in a similar manner to a standard odometer in a car. 10.1.2.0 plus 1 would equate to 10.1.2.1. Or if we went in reverse, 10.1.2.0 less 1 would give you 10.1.1.255. In a standard odometer, the values can go from 0 to 9. In a binary odometer, the values can go from 0 to 255. And then they have to click over in the next octet. Thus, if the last octet is equal to 255 and you add 1, notice the third octet clicks over from 1 to 2 and the last octet clicks over to 0. So use this analogy to help you work out the first host, the last host, and the broadcast address. So the broadcast address is equal to the next network that we worked out less 1. So the next network that we worked out was 172.16.48.0, and if we subtract 1 from that, we'll get 172.16.47.255. Just remember how the binary odometer works. Each octet can go from 0 to 255, and then it has to click over, or in this example, click back. So the broadcast address for host 172.16.35.123 is 172.16.47.255. We worked this out by leaving the network portion the same, in other words, the first 2 octets in blue, and then the subnet and the host portion is set to 1 less than the next network, which in this case is 48.0. To work out the first host in the same subnet, take your subnet and add 1 to it. So the subnet that we've worked out is 172.16.32.0, and if you add 1 to that, you get 172.16.32.1. The last host is equal to the broadcast address less 1. So 172.16.47.255, which is our broadcast address, less 1 is equal to 172.16.47.254. And that's it. You've worked out the answers to the question. Now initially that might seem like a lot of work, but you should be able to start doing examples within 30 to 60 seconds using this method, thus the quick method. So to summarize this example, 172.16.32.0 is the subnet for host 172.16.35.123 with a subnet mask of 255.255.240.0. The broadcast is 172.16.47.255, and the first host is 172.16.32.1, and the last host is 172.16.47.254. In the second part of this section, we're going to look at how to subdivide a network or subnet when given a specific number of hosts that would be required on a subnet, or a specific number of subnets that are required. So there are two scenarios. When asked for a specific number of hosts on a subnet, you would have to subdivide a specific network or subnet that you were given into multiple subnets that can support that number of hosts. Or you may be required to subdivide a subnet into multiple subnets. Why would this be required in the real world? Well, you might be the administrator of a remote site, and the head office has allocated you a specific subnet. Let's say 192.168.1.0/24. Now that is only one subnet. What happens if you require multiple subnets? Well, you could ask the head office to give you more subnets, but they may tell you that you don't require multiple subnets, and that you are to subdivide that subnet into more subnets. Now, if your site only had two physical segments, with let's say the first segment having 3 hosts on it, and the second segment having 2 hosts on it, it's very unlikely that the head office is going to allocate you 2 separate subnets, because this subnet 192.168.1.0 can support 254 hosts, and you only have a requirement for 3 hosts on one segment and 2 hosts on another segment. So you may be required to subdivide the subnet that you have been given so that you can support this infrastructure. Another reason to subnet is that the original class full networks, like a Class A network, support 16,777,214 hosts per network of 10.0.0.0/8, and you had all of your hosts on that one subnet, the network would die. The amount of broadcasts and traffic sent on this segment will just destroy the network. It's not practically possible to have so many hosts on a subnet. A lot of network engineers will put a maximum of 254 hosts on a subnet. In other words, they would subnet down to a Class C subnet. Class B networks support 16,382 hosts per subnet, and once again that's far too many hosts on a subnet or network. That segment will not operate properly with so many hosts within that subnet. So once again, we will more than likely subnet down to at least 254 hosts on a subnet. On a point-to-point WAN link, only 2 host addresses are required. So it makes sense to subnet down even further, or subdivide a network down even further, until you only have 2 hosts on that subnet. The formula to work out how many hosts are supported on a subnet is 2 to the n minus 2. Where n is the number of binary bits in the host portion. So as an example, a Class A address is 32 bits in size, where 8 bits is the network portion, and 24 bits is the host portion. So 2 to the power of 24 equals 16 million odd addresses. You subtract 2, 1 for the network and 1 for the broadcast. So 16,777,214 hosts would be supported in theory on a Class A network. In reality, that would never work. It's thus important that you understand subnetting and understand this section for the real world as well as for study purposes.